we're going to talk about deferred execution of programs. So far, our web applications have all generated web pages in direct response to a URL, right? In direct response to an HTTP request. You put in a URL, you press return, our program runs on the server, it generates a page, or maybe it executes some code and we see it. That's roughly equivalent to when we're writing Python programs that we're running on our device. We would run the program and it would run. Right? That's kind of the simple way of doing things. But if you remember, when we were writing our programs running on our local computer, we also had the concept of a callback, and also we talked about event-driven programming. The concept of event-driven programming is that your program doesn't always run. It essentially sits there and waits for some kind of activity in the world, and then in response to that activity, then your program runs, it does something, it responds as needed, and then goes back to sleep. And if you remember, we talked about there being 3 core kinds of activities that could wake up your program and cause it to run. There were user events, user input events, so maybe a user clicked something, or they typed something, or they moved their mouse. Basically, a human directly interacted with a computer, and the computer program had to respond to that user input. The second was that there was some kind of timer. Your program would go to sleep, and then a timer would be set, and then at some point in the future, the timer would tick, the program would wake up and execute your bit of code. And our simulations use that to respond to a timer, to have the little creature move around on its own. We had a timer set up so that every 100 milliseconds, or 10 times a second, a timer would tick, and our simulation would go forward one step. The third kind, which we haven't implemented so far, is in response to network traffic. Right? There's some kind of communications that comes into the computer that wakes your computer up and causes your program to run. We actually did have some of that in just the last project with our little text bot. Right? If you send a SMS to your program wakes up and responds to that SMS, it generates some text and sends it back. In that case, we wrote the code that responded to the SMS, and then our program called your program. But conceptually, right, we were responding to network traffic. So we have in this class already seen all 3 ways that programs can respond to external requests. These are all various forms of deferred execution. Right? You sort of set something up, your program goes to sleep, and then later in the future, they respond. So we can do the same sort of thing on the web. Even if our code is running on the server, we still might want to write some code that is there waiting to respond, but doesn't actually respond until something happens. And there's lots of reasons that we might do this. Similar kind of motivations as when we were running our programs locally. But there are other examples too. In fact, let's look at Gmail. There is a common feature called undo. Right? I can send myself a message. I'm going to send this and just say test and say I hate you. Right? I'm really mad. I send a message. And then right after I send, I say, you know what? Maybe that wasn't such a good idea. Let me quickly undo that. Whew, undo. Right? I don't really hate you. That was a bad thing to say. I love you. We'll let that one go through. The point is, somehow, there's something tricky that happened here that let me undo this message. How did that work? Well, when I pressed send, it didn't really send the message. Instead, what happened is we should, the server sets up a timer so that when the user presses send, the timer gets set up so that maybe 5 or 10 seconds in the future, the message actually gets sent. So I press send, a timer gets started, the computer goes to sleep, the timer ticks in 10 seconds, and when that timer ticks, the computer wakes up and sends the message. There are lots of times when we might want to do this. Another really important time is when we want to run some code on our server that's slow. So a user presses something, right? They say, okay, go. But maybe the operation is computationally expensive and it's going to take 60 seconds, or maybe even 10 minutes. It's going to go do some really, big computation. You certainly wouldn't want the user sitting there for 10 minutes. So instead what you do is the computer responds right away. The user interface responds, but the request has been made. It gets put off onto some kind of deferred execution mode, and it gets executed later in the background, and it's okay if it takes a long time. And in fact, for Google App Engine, when you're writing the kind of code we've been writing so far that responds right away, those codes have to run within 60 seconds or they'll get shut off. Google App Engine won't let your code run for more than 60 seconds if it's in response to user input. On the other hand, if we do one of these deferred inputs, then it can run for much longer. I think the limit is 10 minutes, but we could actually look that up and be sure.
To get a sense of how task queues work in Google App Engine, we're just going to visually represent what's going on. What we've had so far is a web browser where you would type in your URL, right? And when you would enter your URL, that URL would get sent into the cloud where a program on a computer would run right away, right? Our Python program on Google App Engine would run right away and return HTML, which would get displayed here. That's the essential model for how web responses work. The idea of a Google App Engine task queue is directly built on top of this essential infrastructure. We still will have URLs that cause HTML to be generated, or for your code to do anything else that you want. But rather than your code being run in direct response to a URL being entered into a web browser, instead, your program gets set up on a task queue. So this Google App Engine task queue is essentially just a list of URLs that get added by your program. Then Google App Engine will go through the task queue and, as it has time, go and execute that code. So more specifically, what's going on is a web page gets loaded, your code gets executed. When your code is executing, it can set up some other code that you want to run with deferred execution. So what your code will do is put onto the task queue some other URL. And maybe it'll put on multiple URLs. Then your program will return, your system will go to sleep, and Google App Engine, when it has some time, and it might be very soon or it might be scheduled to come up later, your Google App Engine task queue will then go take the first item off the task queue, the first URL, and essentially just load that URL, which will cause your program, your Python program, to run. Now that Python program, since it's running in the background, it doesn't make any sense for it to generate HTML. So it can't display anything to the user, but it can execute any Google App Engine code that you'd like, any kind of code that you'd have written before. So it can do some computation, it can read from a database, it can write to a database. Then later on, when something user visible happens, like someone else opens up a page, they can also access the database and see how the database was changed. Or maybe your code will do something more direct, like maybe it will email a user, like we saw with the Google account activity. So that's the essential structure of the Google App Engine's task queue.
So these are various kinds of deferred execution. These are sort of one-offs, right? You sort of set it up and it goes. Google App Engine has a mechanism to support these kinds of one-off executions called task queues. A queue is just sort of a way to line things up and wait. And a task queue is a way to line up a bunch of tasks and say, go ahead and implement them later. So we're going to dive in a little bit and look at what the Google App Engine task queues look like. There's another kind of deferred execution, which is to say I don't want to do something just one-off, just once, but I want to do it with some regularity, once a week or once a month or every day. I set up some schedule so that every so often something executes. And there are lots of examples of this. I get email, for example, from Google's account activity program, and about once a month I get an automatic email reminding me that my account activity report is available. Well, there probably isn't an employee at Google once a month that is going and sending me an email, right? This is all automated, of course. So that means there has to be a program that once a month wakes up, executes some code, and sends me a mail. So this concept of sending something with regularity is typically in computer lingo called a cron job. Cron like Chronos, something that happens over time. And we'll look at that in a little bit more detail as well. The last thing we're going to look at is a slightly more sophisticated way of generating HTML pages that separates the concerns of writing our Python code on the server for the computation and the HTML, which is the visual display for the user.